Today we will be graphing linear functions. Truly, this is the third and final part of our algebra review. Before we jump in to today's lessons, I'd like to tell you a little riddle. Why was the pitcher sent to jail? It got framed. Get it? A picture in a frame? Okay, whatever. Okay, so when we say graphing linear functions, we're really just talking about graphing straight lines. A little bit later in the year, we'll talk about what it really means to be a function and pass the vertical line test, and each x maps to a unique y, and we'll talk about that a little bit more. But for now, let's look at slope-intercept form, y equals mx plus b, where m represents the slope, and we like to characterize that as rise over run. So I always like to write my slope as a fraction. And the y-intercept, b, just tells you where the graph crosses the y-axis. For example, if it's up 2, we'll say that b equals 2, or we can also say that that intercept is 0, 2. So we can write it as an ordered pair. Also, in our textbook, you may notice that they use f of x in place of y, but it means the exact same thing. Let's see if you recall from algebra how to graph y equals 2x minus 3. The first thing I'm going to recognize is that my slope is 2 and that my y-intercept is -3, or you can think of that as 0, -3. Okay, that's always on the y-axis. Never, no, do not go to the x-axis. That's a common mistake. We go to the y-axis, and now the slope, I like to write it as a fraction, where 2 is the rise and 1 is the run. So when we say rise, if it's positive, you start at the intercept, you go up 2, and then run 1. So I went up 2 steps, and then I ran 1. And let me put that so you can see. Up 2, because the 2 is positive, and then I ran 1. And see, this is the positive x-axis, and this is the negative. So when you run forward, you run towards the positive. If you rise, you go up for the positive y, and then this is the negative y down here. So that line is going to go through here. Let me make that a little straighter. So there's our line, y equals 2x minus 3. And I just really want to make sure everyone understands. Notice we started at -3 on the y-axis. We went up 2, we ran 1. Let's try another one. Here, we want to start by identifying our slope and our y-intercept. So the slope, there's nothing there, but remember, a coefficient, even if it's not there, is 1. And remember, you can always put anything you want over 1. And there's nothing added here, so you could think of that as adding 0. So I'm going to go to the y-axis and put a point at 0. And now I'm going to rise 1 and run 1. And you can put more points, up 1, over 1, up 1. And we can go ahead and graph that line. And that is the line y equals x. That is a very popular line in math. I wanted to make sure you know about it. And notice it says y equals x. So every point on this line, even here, -3, -3. Notice the x and y coordinate are equal. And that's true of every point on that line. Let's move forward and graph y equals negative 1/4 x. Now, the negative sign sometimes confuses students, so I want to make sure that this is very clear. Again, we're going to start at 0 on the y-axis. And now I'm going to rewrite my slope as negative 1/4. You can choose to put that negative sign in the numerator or the denominator. And I'd like to quickly show you that it means the same exact thing. So, a negative rise actually means to go down, okay? So, negative rise means go down 1 and run 4. 1, 2, 3, 4. Okay, so that's our line. But I'd like to show you that it would be the same thing if I thought about rising, going up positive 1, and then letting my run be negative, which just means run backwards. So if I start at 0, and let's change the color just so that we can see it's the same. Start at 0 and then go up 1 and then go back 4, it's still the same line. So it doesn't matter if we go down 1 and run 4 positive, it's going to be the same line regardless of how we do that. Hope that makes sense. Okay. Now I'd like to make sure you understand how to graph using x and y intercepts. This is standard form. Some textbooks may also say that it's ax plus by plus c equals 0. So the sign on the c may be opposite, but that's okay because we're really focused on a and b more than anything. But let's do the standard form in blue for now. What we're going to do is if a line is in standard form, we're going to find the x and y intercepts. So to find the x-intercept, you're going to make y equals 0 and solve for x. Or to find the y-intercept, we're going to make x equals 0 and solve for y. Now this is a very important disclaimer over here. This technique is for graphing, not for solving. I've often had students get a little confused. So, before we even get into this, I definitely want to say, yes, you can convert this to slope-intercept form, okay, by moving your 2x over, making it negative, and dividing everything by -4. This is definitely one way to do it, where we start with -2 and go up 1 over 2, up 1 over 2. You most definitely can graph this line that way. Okay? But I'd like to show you another way. And there's definitely a reason why you need to learn how to graph by intercepts. As a matter of fact, let me tell you, the main reason is for lines, you have slope-intercept. But when we get into more complicated functions, there is no slope-intercept. If you're graphing y equals x to the 5th power, you need to understand intercepts and what it means to make x equals 0 or y equals 0. So, with that being said, let's go ahead and graph this using intercepts. I always like to teach concepts using simple problems. Okay, so let's go ahead and find the x-intercept. So to find the x-intercept, our directions said make y equal to 0. and solve for x. So this means our x-intercept is 4. So we go to the x-axis and put a point at 4, which you already see there. Now to find the y-intercept, we're going to make x equal 0. You always do the opposite variable. Dividing both sides by -4. And so now I can see my intercept is -2. And there's our line. Okay. And that is the same line that we can come up with by using slope-intercept form. Now, I'd like to show you this technique at full speed, okay? So I am going to go back one more time. I'm going to erase this just because I want you to see how easy this technique is. Okay, so what we're going to do is use the cover-up technique or the cover method. If I'm looking for the x-intercept, I'm covering, oops, I didn't mean to do that. I'm going to ignore this, okay? So what I really have is 2x equals 8 or x equals 4. And most of you can even do that in your head. Then if I were to x out the 2x, I could still see that that's -4y equals 8 or y equals -2. And I can quickly see where these lines are, okay? Or see where the points are so that I can graph this line. Now we're going to graph horizontal and vertical lines. Horizontal, okay, and vertical. Now, what I'd like for you to remember is that y equations lay down or they're sideways like the horizon, and vertical lines are x equations. Okay, and I always remember that because I think these lay down and lay has a y in it. I know that's kind of corny, but that's how I remember it. So if we want to graph x equals 2, we go to the x-axis, find 2, and make a perpendicular line through it. That's very fast, very easy. And what I want you to notice is that every point on this line has an x-coordinate of 2. Every single point, even the in-between points, have an x-coordinate of 2. And last but not least, y equals -3. You go to the y-axis, put a point at -3, and zoom. Your line is perpendicular. And just like we said before, y equations lay down.